2 out of 3 women over 50 in the United States are carrying a type of abdominal fat that is actively driving insulin resistance right now, and most of them have no idea. That number comes from NHANES data spanning 20 years. In 2003, clinical insulin resistance affected about 22% of perimenopausal women. By 2023, that number climbed to over 30%, and the abdominal obesity fueling it hit 67%. Those aren't projections. Those are measured bodies, measured blood. I've been wanting to do this video for a while, and a meta-analysis published in 2024 by the Menopause Society finally brought together the data I was waiting for. 17 randomized, placebo-controlled trials, over 29,000 postmenopausal women, and the conclusion was unambiguous. Hormone replacement therapy significantly reduces insulin resistance in healthy postmenopausal women.
Estrogen alone protocols showed the strongest effect. A reanalysis of the Women's Health Initiative confirmed it from another angle. Women assigned to conjugated estrogens had a lower incidence of clinical diabetes with a hazard ratio of 0.88. What keeps striking me every time I go through this research, and I've gone through a lot of it, is that we've had pieces of this answer for years. The women in this community describe the same thing over and over. They eat well, they move, the blood work comes back fine, and they still gain weight around the middle that won't budge. The science behind why that's happening is not new. It's just not making it into the conversation at their annual checkup. And that gap is what this video is about. And this is where it gets personal for women over 50. Before menopause, estrogen does something extraordinary for your metabolism. It keeps a specific receptor, estrogen receptor alpha, active at the surface of your muscle and fat cells. That receptor drives glucose into your cells efficiently. It keeps your body sensitive to insulin, and it tells your fat to store itself under the skin, around your hips and thighs, which is metabolically relatively safe. After menopause, that entire system collapses. The receptor ratio flips. Your fat migrates inward, wrapping around your liver and organs. Your adiponectin, a hormone that acts as a metabolic brake, drops sharply. And your pancreas starts pumping out more and more insulin just to get the same amount of glucose into your cells. Untreated, this trajectory carries a cardiovascular mortality risk 2 to 3 times higher than in women without insulin resistance. And the emerging data linking it to Alzheimer's and breast cancer makes it even harder to sit on. I want to walk you through 7 things today: the biology, the signs your body is already showing you, the tests that actually catch this early, and what the strongest evidence says about turning it around. The last one involves a plant compound that matched a prescription drug head-to-head in clinical trials, and I think the result is going to surprise you. The starting point is a receptor most women have never heard of, estrogen receptor alpha, or ESR1. In 2017, a study published in the Journal of Molecular Endocrinology mapped out exactly how estradiol, the primary estrogen, controls glucose uptake at the cellular level. It promotes a shuttle mechanism that moves ESR1 to the surface of your cells. Once it's there, ESR1 triggers a chain of events, AKT phosphorylation, then GLUT4 translocation, that physically opens the door for glucose to leave your bloodstream and enter your muscle and fat tissue. That's the system working the way it's supposed to. A 2022 study in the Journal of Clinical Endocrinology and Metabolism looked at adipose tissue from pre- and postmenopausal women. What they found was a measurable shift after menopause. ESR1 expression drops and a different receptor, ESR2, takes over. That change in ratio directly inhibits glucose utilization. Your cells become harder to reach. Insulin has to knock louder. And eventually your pancreas is working overtime just to keep your blood sugar in a range that looks normal on paper. That's the trap. The glucose number on your blood panel can sit at 95 for years, while your insulin levels are climbing silently behind it. Your doctor sees 95 and says you're fine. Your pancreas is screaming, and the shift in where your body stores fat compounds the problem, which brings me to the next piece. In the years before menopause, estrogen directs fat storage toward the hips and thighs, subcutaneous fat, under the skin. That pattern is metabolically manageable. After menopause, without that estrogenic signal, fat storage shifts dramatically toward the abdomen, not under the skin of the belly, deeper, around the liver, the intestines, the kidneys, visceral fat. And visceral fat behaves nothing like the fat on your thighs. It's metabolically hostile. It continuously releases free fatty acids straight into the portal vein, the direct highway to your liver. That flood of fatty acids overwhelms the liver's ability to clear insulin properly, drives the liver to overproduce glucose on its own, and locks the body into a state of chronic hyperinsulinemia. This is not about eating too much. The clinical data confirms that this redistribution happens independently of caloric intake. It's hormonally driven. A woman can eat exactly what she ate at 42 and still accumulate visceral fat at 55, because the hormonal environment directing where that fat goes has fundamentally changed. At the same time, adiponectin, a hormone your fat cells produce that normally activates AMPK and keeps your liver's glucose production in check, drops sharply across the menopausal transition. Longitudinal data ties that decline directly to rising blood pressure, rising triglycerides, and falling HDL. The fat moved, the metabolic brake failed, and the consequences start showing up on your skin before they ever show up on your blood panel. Before insulin resistance shows up in a single lab value, it often shows up on the body. Two signs in particular. The first is acanthosis nigricans, darkened velvety patches of skin, usually in the folds of the neck, the armpits or the groin. The second is a sudden increase in skin tags, small soft growths that seem to appear out of nowhere. Both of these are driven by the same mechanism. When insulin climbs to supraphysiologic levels, higher than the body was designed to handle, it loses its specificity. It starts cross-reacting with IGF-1 receptors sitting on the surface of skin cells. That aberrant activation triggers rapid cellular proliferation. The skin thickens, growths form. A study published in Anais Brasileiras de Diabetologia confirmed that these dermatological changes are hallmark indicators of severe insulin resistance. They're essentially your body displaying the hyperinsulinemia externally. Most women notice the skin tags and assume it's aging. Most doctors note the darkened patches and don't connect them to metabolism. But if you're seeing either of these, especially both, the conversation with your doctor should not be about your skin. It should be about your insulin. And if those are the visible signs, the invisible ones are even more revealing, starting with what happens after you eat. You eat lunch, pasta, rice, a sandwich, something carb-heavy, and 30 minutes later, you physically cannot stay awake. Your legs feel like concrete. Your brain shuts off. And no amount of coffee or willpower brings you back. Most people call that a food coma and move on. The biology behind it is more specific and more concerning than that label suggests. A 2023 study published in Nutrients laid out the mechanism. When a woman with underlying insulin resistance eats a high glycemic meal, the pancreas doesn't produce a normal insulin response. It produces a massive, exaggerated one. That excessive insulin surge hyperactivates the sodium-potassium pump across cellular membranes throughout the body. Potassium gets driven out of the bloodstream and into cells at an accelerated rate, creating a transient drop in extracellular potassium. Potassium is essential for muscle contraction and nerve signaling. When it drops, even mildly, even temporarily, the result is profound physical fatigue, muscle heaviness, and a mental fog that feels impossible to power through. Because it is impossible to power through, it's not laziness, it's an electrolyte disruption triggered by a broken insulin response. If this is happening to you regularly, especially after carbohydrate-heavy meals, it's not a quirk of digestion. It's a metabolic signal, and it tends to travel with the next item on this list, which is the one that concerns me the most. So far we've covered 4 pieces. The receptor shift that rewires glucose metabolism after menopause, the visceral fat migration that poisons the liver, the skin changes that display hyperinsulinemia before any blood test catches it, and the post-meal crashes driven by potassium disruption. 3 more to go, including the one that connects insulin resistance to Alzheimer's risk, the blood test most women have never been offered, and the reversal protocol backed by the strongest clinical evidence I've found. This is the one that bothers me the most, because it connects to a disease that terrifies every woman I talk to. In 2008, a research team led by Suzanne de la Monte proposed something radical, that Alzheimer's disease is at its core a form of brain-specific insulin resistance. They called it type 3 diabetes. That label hasn't become an official diagnostic code, but the underlying biology has only gotten stronger since. Your brain is loaded with insulin receptors, concentrated in the hippocampus and the cortex, the regions responsible for memory and executive function. When peripheral insulin resistance develops in the body, the brain follows. Neuronal glucose uptake collapses, and neurons, which depend almost entirely on glucose for energy, start starving. That's brain fog. Not vague, not imagined, cellular starvation, but the damage doesn't stop there. Insulin normally competes with amyloid beta proteins for degradation by an enzyme called IDE, insulin-degrading enzyme. In a state of chronic hyperinsulinemia, IDE is consumed clearing excess insulin. It has nothing left for amyloid. Toxic plaques accumulate, tau tangles form, and cognitive decline accelerates. Running alongside this, insulin resistance almost universally comes with leptin resistance. Leptin is the hormone your fat tissue produces to signal satiety, to tell your brain you've eaten enough. When the hypothalamus stops hearing that signal, the dopamine reward pathways stay hyperactivated. Your brain keeps craving carbohydrates even when your body has more than enough stored energy. The cravings are not a willpower failure, they're a neurological consequence of a broken feedback loop. If you're experiencing persistent brain fog and uncontrollable sugar cravings together, that combination is not random, it's metabolically coherent, and it's testable, which brings me to the diagnostic gap that allows all of this to progress unchecked. If everything I've described so far, the visceral fat, the skin changes, the crashes, the brain fog sounds familiar, the natural question is, why didn't my blood test catch any of this? Because the test your doctor runs isn't designed to catch it. Fasting blood glucose, the number on your standard metabolic panel, is a late-stage marker. Your pancreas will secrete increasingly toxic amounts of insulin for 10, 15, even 20 years to keep that glucose number under 100. And as long as it stays under 100, the system registers you as metabolically fine. You are not fine. You're in compensatory hyperinsulinemia, and the damage is already happening. The test that catches this early is called HOMA-ER. It stands for Homeostatic Model Assessment for Insulin Resistance, and it uses a simple formula, fasting insulin times fasting glucose, divided by 22.5. An optimal score is below 1.0. Between 1.0 and 1.9, you're in early metabolic stress. Lifestyle intervention should start immediately. At 2.73 or above, you're clinically insulin resistant. Above 5.0, you're in severe metabolic dysfunction. Most doctors don't order it. Most labs don't include it on a standard panel. You have to ask. Fasting insulin alone is also enormously telling. Standard lab reference ranges suggest anything between 2.5 and 13 mg/ml is normal, but those ranges are based on population averages, and the population is increasingly metabolically sick. Functional thresholds put optimal fasting insulin below 5 to 6 mg. And if you want a number you can calculate tonight from a blood panel you already have, the triglyceride to HDL ratio. A 2021 study in Endocrine Connections identified a critical inflection point at a ratio of 1.06. Below that, insulin sensitivity is generally maintained. Above it, the risk of clinical insulin resistance accelerates exponentially. For adult women specifically, a ratio above 2.53 is considered confirmatory. This ratio is especially powerful for identifying what researchers call the TOFI phenotype, thin outside, fat inside. Women with a perfectly normal BMI who are harboring dangerous visceral fat and severe insulin resistance internally. BMI misses them entirely. The TG/HDL ratio does not. Ask your doctor for fasting insulin on your next panel. Calculate your HOMA-IR. Check your TG/HDL ratio. These three numbers tell you more about your metabolic trajectory than fasting glucose ever will. Now, this is the part one wanted to get to from the beginning. The clinical literature on reversing insulin resistance in postmenopausal women is not ambiguous. It's not more research is needed. It's robust, and the interventions that work are not extreme, they're specific. Diet. The Mediterranean diet has the strongest evidence base of any nutritional protocol for resolving metabolic syndrome. The bioactive compounds, polyphenols, omega-3s, the oleic acid in extra virgin olive oil, interact with a nuclear protein called HMGA1 to reverse the molecular signature of insulin resistance. A randomized controlled trial specifically targeting postmenopausal women combined a strict Mediterranean diet with 40 milligrams of daily soy isoflavones. The group that followed the protocol saw massive reductions in HOMA-IR scores compared to women who received basic lifestyle advice alone. Time-restricted eating. An 8-week trial using an 18-6 protocol, eating only between 1 p.m. and 7 p.m., found that postmenopausal women achieved significant reductions in fasting insulin, total fat mass, and oxidative stress markers. And they did it without losing lean muscle mass. That last part matters enormously, because muscle preservation is the single biggest concern in this age group. Resistance training. Your skeletal muscle is the largest glucose sink in your body. The more muscle you carry, the more storage capacity you have for glucose. That's called the mass effect. When clinical trials compared resistance training plus aerobic exercise against aerobic exercise alone in postmenopausal women with type 2 diabetes, the combination produced superior glucose disposal, greater visceral fat reduction, and better overall insulin sensitivity. Walking is valuable, lifting is essential. Sleep. A 2023 randomized clinical trial at Columbia University proved something many women already suspected. Chronic short sleep actively causes insulin resistance. When women were restricted to just 6.2 hours per night for 6 weeks, their insulin sensitivity deteriorated significantly. No change in diet, no change in weight, sleep alone drove the metabolic damage. A separate crossover study found that restricting postmenopausal women to 5 hours of sleep for just 4 nights produced a 20% reduction in glucose infusion rates. Sleep is not a luxury for metabolic health. It's infrastructure, berberine, and this is the one I mentioned at the beginning. Berberine is a plant alkaloid that has been compared directly to metformin, the most widely prescribed drug for insulin resistance in multiple clinical trials. It works through the same primary mechanism, AMPK activation. It stimulates glucose uptake in muscle and fat tissue, suppresses gluconeogenesis in the liver, and reduces HbA1c and fasting glucose. Across rigorous trials, the glycemic reduction was statistically equivalent to metformin, and berberine actually outperformed metformin in one critical area, lipid correction. It lowered total cholesterol and triglycerides more effectively. One important caveat: berberine has poor oral bioavailability and heavily inhibits liver enzymes involved in drug metabolism. If you're taking prescription medications, that interaction is serious, and you need to discuss it with your doctor before starting. What I keep noticing in the comments on this channel and in everything I read on this topic is the same disconnect. Women doing everything they were told, clean blood work, good checkup, and something still breaking underneath. The science is clear. Insulin resistance in postmenopausal women is driven by specific identifiable hormonal shifts. It manifests through specific visible signs. It's measurable with specific available tests, and it responds to specific evidence-backed interventions, none of which are extreme. The Mediterranean diet, time-restricted eating, resistance training, protected sleep, and targeted supplementation together, these don't just slow the progression. The data shows they reverse it. HOMA-IR scores drop. Visceral fat recedes. Fasting insulin normalizes. Brain fog clears. The fix isn't complicated. It's just completely absent from the standard metabolic workup most women receive. And that absence is costing women decades of metabolic health they could have protected. I want to try something with this video. Go find your most recent blood panel or ask your doctor's office to send you the results. Look for your fasting insulin number, not your fasting glucose, your fasting insulin. If it's listed, drop it in the comments. If it's not on the panel, and for a lot of you it won't be, I want to know that too. Because how many of you have never been tested for the one marker that catches this earliest tells me everything about where the gap actually is. If your number is above 8 or if it's simply not there, bring this video to your next appointment. You are allowed to request this test. And if your fasting insulin is already climbing, here's something your doctor almost certainly hasn't told you. Insulin resistance doesn't just damage your metabolism, it stiffens your arteries. And stiff arteries drive up a very specific number in your blood pressure reading that most women over 50 have never been told to check. I broke down exactly what that number is, why it matters more than your systolic reading alone, and what the Women's Health Initiative data says about the risk it carries in the video right here. If insulin resistance is the engine, that number is the warning light. Watch that one next. Everything I've shared today is for educational purposes only. Please talk to your doctor before making changes to your health routine, especially if you're managing existing conditions or taking medications.